thank you for sticking with us till the last session of the day before the final closing notes. My name is Michael Brunton-Spall. I'm a technical architect with the Government Digital Service. Has anyone here heard of the Government Digital Service? Actually, quite a lot of you. For those of you who don't know, that means that I'm part of the Cabinet Office. So I work for the Queen, kind of indirectly. She doesn't know I work for her necessarily, but I work for the Queen. I'm here to talk about building securely with Agile. If any of you thought you were here for anything else, now's the time to leave without being embarrassed. If any of you have heard me speak before and you want to leave now quickly before so that I don't pick on you, you're more than welcome to. What I'm mostly going to do is cover about how we can continue to build software in a secure and secure manner while still doing Agile, because I think the government has tried to embrace Agile in a whole new way, and government is a world of IT that is not exactly renowned for building software fast or well or cheaply or any of the things that Agile delivers. And so, as I said, I kind of work for the Government Digital Service. We were set up about 4 years ago with the main aim of our mission was to make government IT less shit, which is quite a good mission because it'd be quite hard to make it worse. So that's always quite nice. And so what we do is we got together existing civil servants who were littered across government who were really skilled. We brought in people from really, high-profile organizations, the BBC, The Guardian, Google, Yahoo, people like that, people who built web properties at scale. And we got them into government and said, what can you do if we show people how software development has changed since, we were writing in COBOL, which some of them still do to a day-to-day basis. And we said, let's build things quickly, fast. We'll build it in Ruby, we'll build it in Python, we'll build it in Scala, we'll build it in Go. We'll use new ways of doing stuff in government. And over 4 years, we've really cemented our reputation, I think, for actually delivering on what we say, of demonstrating that Agile techniques can work, they can work in government, they can deliver good quality software. But one of the areas that we're increasingly running up against is the area of security. It's the area of saying we can do this stuff when national security actually matters. If I want to rebuild a system in government that pays out 10% of national debt as a proportion of money, if it pays out billions of pounds per year to citizens, it kind of matters that there's at least some security thought in that process. And a lot of the pushback that we get is Agile can't do that. It's not possible. So I've spent the last year or so, year and a half, actually looking at how to build software in a sensible manner that's secure and uses Agile and so forth. And I think a lot of the things that I've learned over that time would be really applicable to the sorts of work that you do, the sorts of work that many of you probably do in this today. But you might not believe me. So I kind of want to start by giving you, it's a bit what we would call in government a threat briefing. So we would explain what the threats are, what it is that we're actually concerned about. And really, when you're building computer systems, particularly online computer systems, you're worried about 3 things primarily. You're worried about data loss and theft, you're worried about criminal organizations, and you're worried about advanced threats. So data loss and theft, that's the one that we all know about. And this is actually an increasingly growing risk. You see it in headlines day in, day out, all the time. You see that people are losing data in various different ways. This is a slide from Information is Beautiful that shows data loss and theft in IT in 2005 and 2006. And you see a couple of large losses of data. But the key thing to know here is that the red bubbles are the ones that indicate that that data was stolen by hackers, by somebody actually coming and stealing the data. The purple bubbles, this one down here, the automatic card processing, the Texas Lottery at the top, and Dynapan printing, those were insiders who took the data from somewhere they were allowed to get the data and sold it separately. So that's a different kind of threat. And then the grey ones, the one that everyone tends to remember is the UK Revenue and Customs, who put some CDs in the post and they didn't turn up at the other end. And they had 25 million records of people on. That was a bad thing. That's where data was just lost for some reason or another. That's what it looked like in 2005 and 2006. In 2014, this is what it looked like. you can see the amount of intrusions of people attempting to go and collect data, of stealing data from systems is much, much bigger. You look at some of the other more interesting ones. The purple one there, Mozilla. Mozilla accidentally misconfigured the Mozilla Developer Network to publish their data sanitization process for open sourcing all of their databases. They misconfigured it and forgot to sanitize the database, so they lost some data. Twitter was hacked. 250,000 details were taken. The New York Times was hacked for staff details. Most of these things were done by professional hackers. This is no longer the remit of amateur hackers who just come by with some tools and just steal a bit of stuff. Many of these systems were PCI compliant, and then yet they still managed to get hacked and lose data. Many of them didn't expect to be targeted. But that's not it. That's not the only thing we worry about on the internet. Because actually, just like there are criminals sometimes when, in the street or when you go to the pub or whatever, there are people who wish you harm. On the internet, there are also criminals who wish you harm. It's kind of a fact of life. There are criminals and so forth out there. And one example I can tell you about is the Game Over or Zeus banking malware. Has anyone heard of the Game Over malware or Zeus? One or two people. So it's a particularly nasty bit of malware that people were infected by, and it deliberately attempts to steal your banking credentials. And it does it in quite an interesting way. Once your machine is infected, what it does is it actually changes the HTML on pages when you visit certain sites, because it runs kind of in your browser. Which means you can be visiting a site over HTTPS, you can think it's secure, you can see all of the information you want, you can be asked for your PIN details, but what they do is they add some extra fields that say, enter your full PIN, or enter your credit card number. And you go, but this is a bank. I trust them, they trust me, this is a perfectly reasonable place to put that data in. And then they steal the data from there. And they might also go in and initiate transfers from inside your browser. And the key thing about this is, that's a kind of a nasty attack, and amateurs were doing that a number of years ago. But the fact that we talk about criminal use on the internet is it's not just that. It's the fact that the Game Over malware was actually part of an entire criminal ecosystem. So the person who stole your bank details probably didn't infect your PC. What happened was spammers would be paid money to deliberately spam tens of thousands of people, hundreds of thousands of people, to infect their machines. Those machines that were infected, they would sell to groups who would then rent out your machine. They would categorize your machine based on the sorts of things you browse. So what kind of bank did you browse? Things like that. And then another criminal gang who can actually make off with the money would then rent, essentially, you from that organization. You can go to a market and say, I would like 1,000 NatWest users. And they will go, yes, we have that, and we can sell it to you for this amount of money. And then they have just those NatWest users. And then they take the money, but they're not the only ones who actually, they don't get the money out, they just transfer it to other people who then transfer it, and so forth. And it's an entire ecosystem of criminal users on the internet who are trying to do things. And one of the key things about that is, suddenly, just because, if you know, like if I deal with tens of millions of pounds being transferred through my system, I probably know I'm a target. But no longer is it like that, because some people can just infect me and then sell me to people who are interested in me. And that's where we start getting to these advanced persistent threats. That's the buzzword of the year if you're in information security. Everyone's talking about APTs, or advanced persistent threats. For various reasons, I can only talk about ones that are what we call open source, where the information was published by commercial organizations, and all this information comes from there. The links are at the bottom of the slides, and I will publish them later. But I'm going to talk about two of them in particular. This is a group called Fin4, and they've mostly been targeting pharmaceutical and legal firms. But what they were doing is they're looking for pharmaceutical firms who are about to merge with other pharmaceutical firms. And so what they did was they would target pharmaceutical firms with phishing emails that contained malware. They would get onto the person's machine, and they would send internal emails to other members of staff to attempt to spread around the organization. Those emails would be in perfect English. They would reference financial terms and pharmaceutical terms. They were very well written and very strongly targeted. And they were specifically trying to move from organization to organization to find out information about pharmaceutical firms that were merging, for mergers and acquisitions departments. Once they were there, the suspicion is that they were then using insider trading to be able to actually make money on it. But nobody really knows who they are, what money they made on it, or whether they're still active. All we know is that there are sets of these activities that are going on. It's shockingly effective. If you're not in pharmaceuticals, it probably doesn't bother you too much. This one probably should. So this was Caroso. And what happened was there was an advanced persistent threat who wanted to target people who worked in energy and intelligence and defense organizations. In order to do so, they realized that the people in those organizations often read Forbes.com. So they hacked into Forbes.com and they looked at, do you remember, if you ever been to Forbes article, you get the thought of the day, the little thought of the day thing that prevents you reading the article for 5 seconds? They replaced that flash banner with a flash banner that contained a 0-day exploit in Adobe Flash that would look at your IP address and work out if you were in one of the targeted organizations. If you were, it would then download a new bit of malware onto you, and only if you were in a targeted organization, that exploited a second 0-day on your machine to break into your machine. Again, if you work in defense, you probably care about, very advanced hackers attacking you. If you work at Forbes.com, you probably didn't until this happened. Suddenly, everyone on the internet is starting to realize that we're interconnected, that what matters to other people matters to you as well. But it's okay, that's dark and scary. The internet's a dark and scary place. It's kind of what, we find out when we start doing stuff in government. But we've got information security. We've got security people in our organizations who can help us. And the state of information security today, mostly it's words like this. Until a year and a half ago, 2 years ago, when I joined the government, I'd never heard of the term accreditation. I knew about PCI, which is a form of certification. I'd never heard of approval to operate, which is, again, a government-y type thing. But you see in more highly regulated industries, you get the sort of certification that means you get a process that looks like this. The key thing here is in order to build a secure system, I have to ensure I've built a policy, validated my requirements, logged my decisions. I have to ensure I've stored my business case before we started. And we have over here, we have to make sure we've got project plans for each individual project to make sure they work. We have to build corrective actions and make sure we have a compliance review. We have to store all of that information in the appropriate places and follow 27001. That's how I build it. Once I've built the system, in order to put a change live, I have to go through a change management process. This is the ITIL change management process. This is a sort of process where I have to submit my desired change to my Apache config to a change management board of 22 senior managers who will look at my Apache config change and decide whether it's a critical config change, whether it's only a normal change, and whether it'll go into the logging and review, whether it's been assessed by the change manager. Is it minor change, in which case it could be deployed, but it might actually be a major change, in which case it has to be scheduled, and then it has to get a change deployment authorization form filled out and filed, so that everyone can audit where we've been. I worked in an organization in government where when we went in and said we'd like to do Agile, they said to us, that's really nice, we already do Agile, and we asked, how many times do you deploy a year? And they said, twice. I said, oh, so it takes you 6 months to get a piece of code live. And they were like, well, kind of, but we have a 3-month testing cycle before we can release. So the code has to be ready 3 months before the deploy date. And because of that, we have a bunch of features. So we only have a 6-month live cycle before that. But in order to get the features into the development cycle, because we don't disturb the developers while they're working, we have a 6-month requirements process before that, which meant you had a lead time of 18 months to get a feature live on a government site. And if you missed the change meeting that you wanted to go to, you had to wait 6 months to get on the next 18-month program, so you'd be 24 months away from getting a change live. So we said, that's crazy, and we went to go have a look at their last set of changes. Every single change in the previous deploy had been sponsored by a senior manager to avoid the process. So they had a massive, complicated process to keep everything secure, which they then all avoided by getting the appropriate board member to sponsor their change through. And Agile changes everything. When you start saying, we want to release 6 times a day, GovUK, GDS, we released 6 to 12 times a day. We released 25 apps the other day because there was Rails vulnerability and we updated everything simultaneously. We do lots and lots of changes per day. And you get things like minimum viable product. We say to people, build something small and then launch it and then get feedback from real users and then iterate on it. Only do what's needed now. Do regular releases all the time. Keep iterating and so forth. And that, from a security person's perspective, is a complete nightmare. How do I know what applications are live at any one time? How can you possibly go through that entire flowchart in just the 2 hours between one release and another release? I'm going to have to arrange a chat. We had somebody suggest they'd have a change advisory board that would meet every 45 minutes in order to check each change. It doesn't work like that. So what we have to do is we have to work out how we deal with it. So what we did in government was we said, we need to stop building information security systems that are check boxes, that are checklists of going through, checking everything off, following ISO 27001 and ITIL, which a lot of people followed without really understanding why. Some people did. When we spoke with sensible people in government, they were often very frustrated. They knew ITIL back to front, and they knew that what they were seeing was not what was intended. But in government, it was very easy to become, oh, if you haven't got all the checklist from the book, then you clearly haven't thought about it enough, regardless of whether it was appropriate. So we said, we're going to stop with rules. And we released a set of principles. We said we're going to start guiding people with principles and say, you have to think. You can't just say, it's acceptable if it passes the rules. You have to say, here are some guiding principles. You have to write some statement that justifies why you do whatever you do. And so we published 8 principles. Those principles, there's a URL at the bottom. We said they are accept uncertainty. You can't ever be certain of anything. Security is part of the team. It's not something external. Understand the risks of what you're doing. Trust the decision-making in the team. People in the team are able to make decisions. You should trust them to do that. Security is part of everything you do. It's not add-ons. It's not like just the web application firewall. Security is part of the entire process. User experience is important, is really important. If you build a system that's really secure and unusable, your users will work around your security features and it'll be worse than it was. You should audit decisions. You should know when you made a decision and just record it in some way, shape or form. So you can go back at a later date and say, why did we make that decision? Oh yeah, it was a sensible thing to do. And you should understand the big picture impact. Those are our principles. That's it. That's the guidance to all of government. Start doing security like that. And they all went, what does that mean? We don't know. So I thought I'd get practical about some of the things that we've tried doing, some of the things that we're doing in different parts of government. The first one is my personal favorite and is the one I'm going to spend the most time on, assuming I have enough time, because it's something that I think is quite exciting, but I think everyone should be doing, and it's something we should all be doing really easily. And that's automated penetration testing. How many of you have had to submit your application for a penetration test? So those of you who haven't, a penetration test is when you get basically a nice hacker to hack into your system on demand, and they then give you a big list of all the things that they found wrong in your application, and you get all embarrassed, broadly speaking. Doing penetration testing, those of you who put your hands up penetration testing, are you also using Agile? Hands up if you're also using Agile as well. How many of you deployed a change to your application the day after the penetration test and didn't re-penetration test it? So the problem with penetration tests in general is they take 5 days maybe, could be up to £10,000 or so for that 5 days. If you're in Agile and you do 6 changes, you probably defeated the scope of your penetration test before you got the report from the pen tester, because you probably deployed more changes than they had actually tested before they finished writing the report in Word, because a lot of that £10,000 is them sitting down and writing in Word. It's a really good use of money. So automated penetration testing is the bare minimum level. It's not saying this is a replacement for doing real penetration testing. What it's saying is we should be able to do the penetration testing on our applications continuously as part of our build pipeline, so that every time I make a change, I have some level of assurance that I haven't done anything stupid, basically. Just out of university penetration tester who doesn't know anything couldn't break into my system. And we can do that in a bunch of different ways. The reason that we want to do this is it fills these 2 principles: embed security on the team and audit decisions. So what I'm going to do is I'm going to show you a demo that I put together for a tutorial. There are some URLs at the bottom. If you want to have a play, you can go get the security workshop tool. There's a Vagrant box you can go get, or it's a set of Docker images, and you can get all the code and you can play with it as well. If you're interested, the tool I'm using in this case is BDD Security. If you just want to look at the tool, BDD Security is worth it. What I thought I would do is, for this demo, I would be as hipster compatible as possible. So it's running on Docker. It's microservices framework. It's written in Python and Flask, because I think that's really easy for people to read and be able to see what happens. And we're doing automation penetration testing. I think I checked most of the hipster things there. It doesn't have a message queue in RabbitMQ, sorry. I tried everything else. So let's have a look and see if I can get out of this and bring my virtual machine up. Ah, right. Where is it? Oh, there it is. So this application I've got, as I showed you before, there's it's a simple application. Let me actually just give a quick demo of how it's supposed to work. This is interesting that I haven't. So if I run debug.sh, it'll start the thing. For those of you, has everyone here done Docker? Do you understand what's going on with Docker and so forth? If I just show you the, that's not terribly helpful. So I build a container, and this just does Docker run, and then maps my source code into the container. And I'm using very simple Docker files. So in this case, my Docker file consists of one line from Google Python runtime, and that just assumes that you have an application in /vapp, I think, that has a main.py, and it will execute it. So it's very, very simple. There's a build.sh and some stuff that you can look at to see how the containers are built if you're really interested in the Dockery stuff. But let's get it up and running. So we have a payment API as well. We have a web API. You can see I've been testing it earlier. I have an Nginx instance for various reasons. And then, oh my word, this is trickier than it looks. So if we go to localhost, what we should do is hit my application. So my application is a fake application where you can make a claim for money, essentially. And we have an admin, and my password is password1 because I'm a secure admin, and I've looked it up in the top 10 passwords. That was apparently the top one, so I should use that. I'm ready to make a claim, so I can enter my my bank account details. So my sort code is 123456, and my account number is 1234678 because my bank believes in security too. I update it, so now we've got my bank account details stored in a database somewhere. And when I make a claim, a payment of $1,000 has been queued for my account. And what we can do is there is a queue in the Payments API. Payments API is running in 8082 that says all of the bank accounts that we're due to pay. It's about as simple an application as I could come up with that I could deliberately inject some flaws into. So we do a quick demonstration of the code. It's reasonably simple. That is more or less the entire code for the user API. So we go and get the username and password from the thing. We lowercase it because I've got them all in lowercase in the database. And then we do a select ID from users where name is and password is. And then we return OK if they're OK. And if they're not, we return a 404. That username and password's incorrect. That basically works. You'll just have to trust me on that. So what we have is we have a tool called BDD Security. So what I'll do is I'll demonstrate it first, and it helps if I'm in the right directory. I was testing this earlier. So this BDD Security has a set of stories that are defined in Cucumber in behavior-driven design style. They come out of the box, so as a package I have to change basically nothing to be able to run the authentication stories. So I run the story, and what it's going to do is it's going to use Selenium, the testing tool, to actually start up a web browser, log into the service, and attempt to enter certain details. And by default, I've got a failure. You can kind of see there's a failure there. What we have is, if I just look back, there is a, let's just switch to here. So we have we get a report out, and so what we should get is, this is a lot bigger on here. So we get the user is not logged in. So in this case, this story is password should be case sensitive, which is one of the default things that you've got a CWE 178. That's a common web exploit, something or other. I can never remember what they call because there's about 3 of the things with very similar names. 178, which is very commonly you find systems where passwords are not case sensitive, and case sensitivity makes it harder for people to crack your password. So therefore, there's a test just built into BDD Security that says, try and log in with different cases and find out if they're case sensitive. And it's not, it failed. It gave me an error because I shouldn't have been able to log in, but in fact, I did log in. So we can change that really easily. So in this case, I can change it by uncommenting those bits. We can rerun the test. And fingers crossed, nothing breaks. We should get a set of running tests. There we go. Test has gone green. So now I've got basic security tests. These can be put into my continuous integration environment. I haven't had to do very much to do this. But there's some curious things. How does BDD Security know how to log into my application? How is it actually understands where my application is, where the URLs are, and so forth? And that's about the only configuration you really need to do. So oh my word, that's tiny, 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 tiny. In a config, we tell it I want to use Chrome. We tell it the base URL of my application. We give it some other information about things like what usernames and passwords I've configured for my testing, some locations for Nessus and stuff like that. And then what we have in the is you have to build one class in Java. So this is all written in Java for various reasons. So you have to build a class called workshop task application, and you have to implement certain features. So I'm implementing login and log out, and I have to implement the ability to open a login page, which is just a bit of Selenium text that actually goes and fetches the login page. So the app knows where my login page is. I have to implement the ability to log in, which is type into where I put the username, where I put the password, and click the login button. If I was using two-factor authentication, I might have a fake YubiKey or something. I can put a code in, stuff like that. It's entirely in this application, this bit of Java code's decision as to how to implement login for your application. You have an is logged in. How do I know whether I'm logged in or not? I need to go find something on the page and return true or false to say you are logged in so the app knows. And there's some other bits. We'll come to those in a minute. So that's the simplest thing, but that's not actually terribly exciting. Like, there's a set of authentication stories, and there's a couple of things that are interested in here. So, in fact, let me demonstrate it by looking in here. We should have a story that is about when an authentication credential sent to server, it should respond with 3xx, but it got skipped. And if I look at the report, there's actually a wider report. I think if I go back, we'll see it. Refresh it. So there's a bigger report here, and it can show that I actually excluded 6 of the stories. And you might think, why have I excluded those 6 stories? Well, luckily, these stories are all stored in source control. So I can actually go and see, oh, look, Brunton Small but did a commit on this day, skip the redirect stories, it brings up Zap, so I can do faster tests. So I have an audit log of every decision I made about security decisions in my application. Anything I want to make the test pass should be in here. I can audit it, I can see it. When I tell security people that in government, their eyes pop open. They're like, wow, that's an actual audit log of stuff. Like, nobody can fake what's in there. Like, it's much harder. They're really excited by that, the ability to audit what's going on. And as a developer, we're all used to version control. This is just normal to us. But to security people, a lot of them have never actually heard of version control. Like, it's that scary thing you put your source code in that could be compromised someday. That's, as far as they're concerned, that's it. But actually, this kind of thing really helps them when they start seeing the audit logs, the history, the ability to see how the app has changed over time. Oh, and this is what the stories look like, by the way. So these all come out of the box. About the only thing I've done here, as you can see, is I skipped all the ones with SSL because I couldn't get a certificate onto my Docker instance in time, and it was just a bit of a faff. So I skipped. In fact, you should be able to see ignore tests that need SSL, and all the changes I changed for SSL. But if it's just authentication, that's not terribly exciting. What am I doing for time? Yeah, loads of time. So there are other tests. This one takes a bit longer, so I'm going to kick it off and then talk about it. Fingers crossed, assuming I get that right. I don't know why it recompiles every time. It's a bug. That looks correct. So what it is doing now is it is going through my application, it is doing stuff. It is clicking buttons and so forth. The reason it is doing that is it needs to know, one of these things I said, I'll talk about it later. It needs to know, you need to implement a navigate feature. And that says, I'm going to walk through my application, visiting every screen in my application. So this can get really quite big. But what you want it to do is walk through the standard user stories that happen in your application. The reason it does that is there's a tool underneath called Zap, the Z attack proxy. And what it does is it navigates your application through that proxy, which records every form in your application, every header that came back, every piece of information. So it got that session header that you send back that actually tells it what session cookie you have. And now Z attack proxy is being configured to do a set of tests. So it's doing scanning. If we scroll to our Nginx, which is often quite exciting, you can see that what it's doing at the moment is attempting all kinds of different attacks on my service. It's doing SQL injection attacks, it's doing CSRF attacks, it's doing XSS attacks. You don't have to care what those are because it's doing them for you, which is quite nice. The nice thing about this is the sort of thing that your average script kiddie on the internet is going to do to your application. And it's probably doing it better because unless they can navigate the OWASP website, which is a bit of a pain to navigate, they won't have found Zap yet. So they're probably doing SQL injection attacks by hand. And it's going off and doing that. It should be finished soon. It's about 2 minutes. All of this comes out of the box. It's automated. There we go. Finished. So if we look for app scan, that's not right. There we go. So what we've done is we've run the app scan, so we can go look at the reports for app scan, and what we should see is that something has failed, assuming that I correctly broke the application. It took me ages to deliberately break this, because it turns out I've not done SQL injection in a long time, and I'm so used to using ORMs, I forgot about it. So it found 2 SQL injection flaws. So during that process, it went to the login page, it tried various alternatives of SQL injection flaws, and found a successful flaw, has identified where they are on the login page with the parameter username, on the login page with parameter password, so I can now go try and find them and fix them. As I showed you earlier, these ones are reasonably simple to find because I've already done them. This is vulnerable to SQL injection. For those of you who've not seen that before, you can go look up the details, but trust me on it, that's the problem there. So if we comment that out and comment this back in, which is the correct way of using the ORM, our application should no longer be vulnerable to SQL injection. And if I were to rerun the app scan test, it would find that and successfully tell me that my app was secure. That's a very, very, very quick run through of what BD Security does. It does a whole bunch more stuff. You can do things like it will do port scanning for you. So it'll check each of the machines that you've configured and say, does it have only the correct ports open? Have you accidentally left open port 23 when you meant to only have 80 and 443 open? Have you done other bits and pieces like that? It'll do CSRF and cross-site scripting attacks, and it does an awful lot of stuff just out of the box. It's quite nice to give you a level of confidence that is, I'm not going to be embarrassed and have egg on my face when I give it to the pen testers. And it also means the day after the pen testers leave, my junior developer comes along, has never heard of SQL injection, it's their first week on the job, and they're putting a bit of code in, they write something and the test breaks. And you do exactly what you always do with the junior engineer when the test breaks. One of your senior engineers sits down with them and explains why the test broke, what they did that broke it, and suddenly we have a developer who now understands SQL injection attacks. So we're getting this, again, this safety net of saying, I have some level of security and some level of understanding about my system. I've lost my mouse pointer because I'm running on multiple screens. Let's see if I get that back into the right place. Wow, I've made everything go green. That's impressive. I'm not entirely sure how I did that. So, oh, come on. See, I shouldn't have stopped the application. I've completely ruined my slide somehow. How did I do that? I bet I pressed a button at some point. There we go. Right. Yes, at some point I've managed to press Control A and then something to make them go green. How do you make slides go green? So let's go up and say, what about big picture impact? See if I got that right. So that's one part of it. That gives me some level of confidence that things are working the way I want. What about big picture impact? Like I said, there was a principle about understand the big picture impact. I put this on Twitter the other day in response to something, and I think it's quite a nice concept. Component security doesn't matter if there are fundamental flaws in your business process. You can have the most secure user API in the world that's definitely not vulnerable to any issues whatsoever. But if somebody can actually impersonate another user because they can phone up your telephone system and say, I'm Bob, could you tell me my password? And they go, yes, your password is 123. It's completely pointless. So you have to have some understanding of the business process as well, the context in which your application runs. And I'd argue most information disclosure risks, a lot of the time when you see the stories about it, you find out that most of the issues, like information disclosure risks, are caused by that business process, not by a deliberately vulnerable piece of software or an accidentally vulnerable piece of software. So for example, in that app, I've built something in that says, I've deliberately built a microservice where the payments API doesn't know who you are particularly, but it turns out if you can pretend to be somebody who's compromised the web server, you can, if on the vision you know that somebody's called admin, you can send HTTP requests to the payment server and update the bank details, and it has no idea because it doesn't authenticate you, it doesn't know you have a username and password. So you can do things around building these anti-stories, starting to think about the process end to end, the more interesting areas. Maybe we can automate this. We've been calling this misuse cases in the government, and there are a couple other organizations doing it as well, but we've been using this for a bit. And so we're writing misuse cases that look a bit like this. So they're given when then. They're a simple use case. Given it contains data, when a hacker posts a bank details payments using a username, the payment shouldn't be sent to the criminal. Given the system contains a claim, when a fraudster updates their account to a real customer's address, the payment shouldn't be sent to a criminal. Common attacks you find on places are where if you update your address or you do things, certain processes in the background kick off, and they might take a couple of days to take into effect, and you can have a race condition in your business. It's not just in your software, it's just in your business. Like, it takes a while for the next person to pick up the thing. Those kind of things. hopefully we can execute them just like every other user acceptance test, which means if you deploy a story into your application, you should know that you haven't broken the business process. When somebody comes to you and says, we'd really like you to add this feature, and then you add it and a test goes red, and you can say, oh, that feature means that you can in fact break this thing over here, you can have a much more reasoned conversation with somebody about what the issues are. It gives people confidence that that they haven't had an impact elsewhere, and it gives you confidence in the business process. So an example of that, again, let me try alt-tabbing this time and see if I can get it to come back up. That's it. So an example of this is, instead of running the app scan, mouse pointer, there we go. Oh, no, don't run the app scan. So I have a directory in here that's called misuse tests. And what I did in this case, so I think misuse tests can be built in any language, any framework at all. In order to make it understandable, what I did was I built it in the same tool. So I've used BDD security again. There's no fundamental reason that you have to do that. Let's go. Where's my... There we go. So we can have a steal bank credentials story. Looks like that. We can go and implement them. And what I've done is I've cut out, believe it or not, I've cut out quite a lot of the code here. But I've taken out all of the default bits and pieces so that I only implement things like the payment should not be sent to the inquirer. And those are all implemented in the web application steps. So we have code, I apologize to those who have bad eyesight, to do things like post bank details using HTTP URL encoding, check bank details. These are far less reusable. BDD security, you download it, it's reusable against almost any web application. These are custom to my application. They take a lot more effort to build, but in the case of the business process stuff, those are much more particular to what I do. And so I'm not going to do the demo, but you can trust me, there is a flaw in here, and there's an example fix that you can look at if you go look at the code later to see how I tried to fix it around a microservices-based thing. But I'd like to get back to the presentation. Let's see if this works. But can we do even more than that? What if we could do even more than that? What can we do in an Agile team? Can we do something better around our team that isn't just some security guy implementing a bunch of tests? Yeah, I'm okay. Right. We can choose a security model that's appropriate. If I'm building a banking application that runs ATMs, I'm thinking that actually building it in an Agile method where we don't care about security is not appropriate. If I'm building a system that is a government system that lets you find out the next bank holiday, actually accrediting it like a complete government system would be with all of the things that are there, probably not the right thing as well. So before you start your team, you need to pick the model that's right. I think in most cases this Agile security model is okay, but there are cases where I would say, no, let's do something much more formal. Let's slow down the releases and do formal accreditation. In other cases, I might say, even this is too much effort to be worth it. Know what that is. You need to understand the threats, and I think you need to ensure the team understands the threats. You need to bring the whole team in to have a conversation. Who's likely to attack me? What are they going to target? What are they trying to do? What is it they want? Do they want money? Do they want glory for having hacked your service? Do they want to get customer data out? Those are different things, and people will do different types of attacks, and they get bored in different ways. You only need to defend up to a certain level. If you're defending against people who want glory, all you need to be is just like a door lock. Like, you can learn to pick somebody's front door in about 15 minutes if you go to one of the hacker spaces. Most door locks aren't there to prevent someone breaking in. They're there to make it so that your neighbours are more attractive than you are because their door's cheaper than yours. That's all a door lock is there for. And it's the same with a lot of the security we do. It's there to make sure people have a pop at it and go, that's hard, I'll move on. So understanding what those threats are. Educate those decision makers about the risks they're taking. We kick off a discussion with the service manager, the owner of the business process, your on-site customer if you're doing XP, that kind of stuff, and start educating them about what are the risks they're thinking of taking. They're involved in the threat modeling. They understand it. Normally, they go kind of white about 5 minutes in and start going, oh my God, is it really like that? It's good fun. I like that. And I think the key thing in Agile is making risk decisions on a per-story basis, or per epic basis. It depends how you define your stories, but every iteration, when you gather the stories together and you're talking them over with your business owner, you should be thinking about what the impact is. So you might have a story that says, allow users to enter bank details, be paid by bank transfer. I think that adds risk to the system. Until this point, we didn't hold bank details. Now we hold bank details. We probably need to think about the risks of doing that. But if they had the story of add two-factor authentication to staff login system, it was prioritized ages ago, it's come up, we're talking about how we do it. the implementation of that reduces risk in the system. So we can be pretty happy that actually we're reducing risk by playing that story. One I worked on had a story allow users to enter multiple holiday periods because they're entering how much holiday they'd taken this year. And we allowed you to have one. We had a story to come along and said, allow them to enter multiple ones. Completely risk neutral. Has no real bearing on the risk of the system as a whole. Educating people so we know this iteration, are we adding a lot more risk? Are we reducing risk overall? What are we doing week to week? Can we quantify it in any meaningful way? That helps. And then you say, what do you do about it? This one adds risk. So the example we had around the add bank details, well, I can do 4 basic things around risk. I can avoid the risk. I can transfer the risk to someone else. I can ignore the risk, or I can mitigate the risk. Ignores probably accept generally. So I could say, we're not going to do it. Actually, we'll just send checks out because that's much less risky. We have a system in place for doing that. That's avoiding the risk. I could say, let's not do that. Let's use Stripe or some other banking third party. They'll keep the bank details. We don't have to. Again, I'm kind of transferring the risk to them. They have to worry about keeping those details safe. I don't. I could say, we're just going to do it. Actually, we don't mind. We have sufficient guards in place. We're okay to do it. I wouldn't say that. The product owner or the business owner would say that. Or we might come up with some technical thing we could do. We're going to encrypt the bank details on submission using public key cryptography, and we're not going to store the private key on that server. We're going to store it on the payment server at the back end. That's what we did in the end in this case. It means that we were much less worried about it. We're not holding your details. We have no way of getting your details back out, and therefore everyone's quite happy. We've reduced the risk down to an acceptable level. How you assess the risk? There are all kinds of processes for doing that. Your security team probably know how to do it. But whatever you do, you should record those decisions. I think you should record them in a log. For every story, you should record them. I think you probably have a wiki in some way, shape, or form. That's a good place to keep those things. You have a living document you can keep looking at. Some of you who've worked in really accredited places will know of a risk register, and you have a big spreadsheet with all kinds of stuff in. They're always unreadable. They're never up to date. They're very rarely referenced, and you sit in each meeting and go, you go down the risks, and people go, oh yes, there was something about that one, and you might address 1 or 2, but by the third one, half the people are asleep or on their Blackberries or whatever. Like, they kind of work in some places, but often they don't really work. But if you have something like a wiki where it is up to date all the time and it's updated every time you add a story, what if you connected that risk log to the story tracker? As you play each story, you mark which risks you're dealing with or which risks you're adding, and then you can see, oh, we've just done release 91. Release 91 puts these stories in play, which means these risks are now live and these risks are now countered. And you can mark it. If you use something like Confluence, you can have that connected with your stories and have it cross out risks as you deploy code. At that moment, anyone in the organization can look at your risk log and know that that's an exact up-to-date version of it, assuming you have hygiene around linking them correctly, etc. So when a story is played, the risks get updated. It becomes really clear. And you can even automate that process. You can even start managing that process in a way that's automated. That's a world that we're trying to move towards, a world where it's clearer to everyone who's making what decisions when, who's doing what at the points that they want to do it. And in summary, the thing I've been trying to get across to you from my perspective is I think we have a duty of care when developing software. For too long, we've been developing software where we don't care about security because it doesn't matter to us, but it matters to software users. And as software gets more and more interlinked, it matters even more. The fact that you run Forbes.com and it doesn't matter about your security, or it does matter, but like you don't care about security to a certain level because you're not a target, is not true anymore. The internet and the interlinking of all the applications has made it so that it's really easy to be part of a chain now. And that's a really hard thing. If you want to go implement this, I'm a big believer in principles. These are the principles. Choose the right process for you. Whatever works for you, not for everyone else. Apply some basic principles, work out what they are, and apply them across everything. Dedicate somebody to actually understanding this and making sure you do it inside your organization. And please align security and delivery, because the security team are desperate. They want to do a lot of this stuff. Many of the people I've met in security, they would really like to work this way, but nobody's ever let them. They've never been given a budget. They've never been given time. They've never been given the energy to do it. They just feel like they're shouting into the void. On the other side, the operations team feel like the security team are the ones who always say no. They never understand when things have to be delivered, and they're not involved in the prioritization conversations. If you get them together, just like DevOps from 5 years ago, if you get security and your DevOps team, if you've got a DevOps team, you're doing it wrong, but get your DevOps team and your security team together, you can start doing interesting things. We're still learning in government. Please let us know if this works for you, if you have any feedback on this, because we're still working out how well this works and where it works. And particularly, we know this works when you have lots and lots of money and people to throw at it. Working out how to scale that down is something that I'm still working on. We are, of course, hiring, because everyone's always hiring. If you're interested in coming to work for us, either on the security side or we have a whole bunch of Java developer jobs at the moment, then please have a look at GDS blog Gov UK. Come transform society, stuff like that. Be part of the civil movement. If you didn't like this, you can email me. If you did like it, you can tweet me, because that's public and I like that. If you didn't like it, you can tweet me as well. That's fine. I apologise in advance. This is, in fact, my shortened email address. My full email address is michael.brunton-spool@digital.cabinet-office.gov.uk. But that's quite a mouthful, so I have MBS as well. Thank you very much. I'm aware that was a whirlwind tour, and I have 5 minutes left for questions. So if there are any questions, please feel free to ask. If you're bored already and you would like to go get a drink or food or something like that, then please feel free to leave as well. At the front. So the question is, do I see any overlap with static analysis tools as well? Yes, I think I'm not necessarily a huge fan of static analysis tools, but running a linter, running a fuzz tester, things like that in your build environment, where they work for you, they counter the threats that you have. They're a really good idea. So yes, I think you should be running that sort of the sort of basic sanity checks on your code in your build. That's a really good place. Doing static analysis in terms of a security perspective, which is like where somebody actually sits and takes apart all of your software line by line and module by module and sees what calls what and whether you can derive a formal model for security. In general, it's only relevant at certain specific areas. In an Agile team, it would be very hard to do that, because you'd have to restart it every week or every 2 weeks to really get the need that you want. Because there's 2 static analysis tools. I suddenly realised you might mend the other. So does that answer your question? Yes. Right, so do we have security education, or is it part of the security principles in the team? Government's a bit special, so we have an entire security arm that's dedicated to giving us security advice, that write lots and lots of documents. They've got a whole bunch of people who you can call in, and they're security specialists, so you can call them in if your project is sufficiently scary that you need some specialists in security. Most departments also there's a set of requirements. We have something called the Security Policy Framework that says they must have what we call a departmental security officer who's in charge of security for the whole department. And every project must get accreditation or approval to operate, which means a CIRO, a Senior Information Risk Officer, has to make a decision at project about whether it's allowed to go live, and they're only allowed to make that decision when given a sufficient amount of evidence that the team have in fact built it in the correct way. So we've got lots and lots of security policy people in government. In terms of educating the developers, we're still working on that. So that's where GDS is trying to come in. Is we're trying to get together people from across government. So the Ministry of Justice have an ethical hacker who works on their team. She's amazing, and she's been doing a whole bunch of work with the Ministry of Justice to help them do stuff by working with them. They have some Ruby security specialists. So each department does their own thing there as well. But we're trying to get better at that. So we still have a formal security requirement because it's a legal requirement at the moment. That is one of the things that we're looking at, writing out the new policy and working out what that would look like. The problem is government does everything from building battleships and nuclear power stations down to tiny piece of software, and at the moment we have the security policy kind of applies to all of that. The bits that we're looking at in GDS is only one portion of it, and so I don't want to say, oh, everyone should just abandon all that stuff, because I don't want people to build battleships that way. I think that's a bad idea, generally. Like, I'm an Agile zealot. I really like Agile. Don't build a battleship in Agile. Like there's a reason why we have other modules for doing that. So, yeah, we still have that policy in place. This process makes it much easier to get that accreditation. You don't have to go through a formal process. You have to present evidence that you're making the correct security decisions. This does that by presenting that risk log, by presenting the audit of stories, by presenting the work you've done. We can still gain accreditation without having to do a formal accrediting process, kind of. Any other questions at the front? So the question is, presumably the security tests take a long time to run. Are they part of the build pipeline? What we're looking at the moment is some of the tests only take 7 or 8 seconds. So the authentication one I showed you is really quite quick. If you switch it over, instead of spinning up Selenium and Chrome, if you use HTML Unit or Phantom.js, it's even faster. Those would be part of every build. The one you saw, the app scanning one, that takes about 2 minutes. That's what I would see. At the moment, we're using it in pre-deploy pipeline. So we already do kind of smoke testing. We do integration testing where we put the app we want to deploy into a test environment and run a set of sense tests against it. That's a reasonably common pattern that people have in industry already. We're adding them into there. I'm very keen to not let them get too long. I can't stand builds that take longer than if it's a build, in my mind, it shouldn't take longer than about a minute. Like if you have issues, bar the downloading the entire internet thing that, Maven and SBT and so forth. But the build shouldn't take very long. And before you deploy, you can probably stretch that out to 5 minutes or so, because the deploy taking longer as a pre-deploy step is probably okay. But again, too long and people get bored and wander off and forget what they were doing. So yeah, but we are trying to put them in the automated deployment process and automated build process to make it so that it happens either on every commit, on every merge of a pull request, or on every deploy, depending on the severity and where we want to run the tests and what tools we have available. Hopefully that answers your question. I think that's all we have time for. Thank you very much for coming along. You're more welcome to send me comments and so forth, or catch me afterwards. Cheers.